Hey, thanks for joining me for this 3.12 unit test review or preview. We're going to review for your Unit 3 test. That's all we're about today. Thanks for joining me. We are going to first talk about solutions to systems of linear equations. And there's lots of different ways to do this that we've learned. So the primary two ways are substitution and combination. So we'll do the combination method here because neither of these equations can be easily solved for x or y. And I'll point out that our initial goal is going to be to add these two together in such a way that two of the variables cancel. So, or one of the variables, the variables from the two equations cancel each other out. So we could add them together in such a way that the x's cancel. 2x plus 7x is not 0, it's 9x. So right now they're not canceling. Or we could add them together in such a way that the y's cancel. 5y minus 3y is 2y. That's closer to 0 y's. So I think we'll go with the second choice. We're going to try to cancel out the y's. And to do that, we will we're going to have to change each of the equations. Right now, they're not in the position that we need them to be to cancel out the y's. I'm going to multiply the top equation by the coefficient of y in the second equation. So I'm going to multiply by 3. And when I do that, every term there gets multiplied by 3. I get 3 times x is 6x. 3 times 5y is 15y. And 3 times 1 is 3. Then, changing colors, I'm going to multiply all of the terms in the second equation by the coefficient. That's just a fancy word for that number next to the y, coefficient of y. So each term gets multiplied by 5. In this case, 5 times 7 is 35x, plus 5 times negative 3 is negative 15y, equals 5 times 24 is 120. And there we have it. Now I'm going to add the two equations together, and I hope you can see that my goal has been met. When I add these two equations together, the y's cancel. 15y minus 15y is 0. And that's what I wanted. So I'm going to add the x's together. I'm adding everything together, but the 15y minus 15y equals 0, so I don't write that answer down. 6x plus 35x is 41x. And 3 plus 121 is 120 plus 3 is 123. Can't talk today. I'm very, very sorry. And then we'll divide both sides by 41. And a quick look on our calculator shows us that 123 divided by 41 is 3. So x equals 3. So we had some big numbers, but in the end it came out to be a nice, easy answer. Now the problem with the combination method is that once we find what one variable is, we still have to figure out what the other variable is, and we don't have any super easy way to do that. I'll go ahead and use that first equation again. We can use either equation for this second step. I'll just take that first equation as it was originally written. I'm just going to write it down here. So 2 times x plus 5 times y equals 1. And the x, for the x I'm going to use what I now know x equals, which is 3. 2 times 3 is 6, plus 5y equals 1. Subtract 6 from both sides, I get 5y equals negative 5. Divide both sides by 5, I get y equals negative 1. I take a minute and just pause and make sure that you understand what I did on each step. I didn't necessarily write down what I was doing, but I subtracted 6 from both sides, so 1 minus 6 is negative 5. Then I divided both sides by the number next to the y. 5, negative 5 divided by 5 is negative 1. Okay, now I have an answer. I'm done. I'm actually done with the problem. I have what I think are my answers. X equals 3, y equals negative 1. Before I kind of put that into permanent form somewhere, or write that down, put a box around it, I'm going to take that second equation. I use the first equation to figure out what y equals. I'm going to take that second equation and just rewrite it with my x and y values in place and see if this works out for me. So 7 times x, which is 3, minus 3 times y, which is negative 1, equals 24. 7 times 3 is 21. Negative 3 times negative 1 is positive 3. And 21 plus 3 does indeed equal 24. So that's just a quick check to make sure that I was getting the right answer here. And now I can write down my answer with confidence. So I'll pick a nice dark color and I'll say that x equals 3 and y equals negative 1 is the solution to this system, putting it in coordinate form, x comma y form. And there we have it. All right, moving on. This is actually the same problem, or the same kind of problem. Doesn't look quite as easy, does it? The thing that's difficult about this problem, anytime you see word problems, is that there are contained within these sentences several equations, and we need to write them down so that we can then solve a system of equations. So we'll just look at the first sentence. Before we even do that, well, let's read this. Beth, 6 years younger than twice Joe's age. Some of their ages is less than 33. What's the oldest age that Joe can be? So the first clue we have is we're trying to figure out what Joe's age is. So maybe we'll call that x. So x equals Joe's age. I could have used J. Maybe it would have been better. The other thing that I clearly don't know that's talked about in this is Beth's age, and maybe I'll just call that y. Y equals Beth's age. So I write down, we call this step the define your variable step. So now I can start writing sentences about those two variables, those two things that I'm trying to find out, Joe's age and Beth's age. Let's look at the first sentence because it's first. Beth is 6 years younger than twice Joe's age. Now, each one of those words or phrases that I've underlined should call to your mind a algebra symbol. Right? Add, subtract, multiply, divide, equal to, variables, numbers. Each of those represents something. So let's just go through and take each one and translate it into algebra. So we'll start with Beth. Beth, or Beth's age, we decided that's going to be y. Is, the word is means, I hope you know, equals 6 years younger than. Younger than means lower than or less than. So that's going to be a subtraction problem. Less than is minus. And so it's minus 6. So I'm going to say minus 6. And we're going to have to change the order here. This is one of those little tricky spots when interpreting words. If I say 6 years younger than, it means you take 6 away from what's going to follow. Okay, twice, what does that mean? Hope you know that means 2 times. And 2 times what? Joe's age. Joe's age we decided was x. So there is what that sentence means. I can rewrite it with a little bit of reordering help. Y equals 2x minus 6. And that again means that Beth is 6 years less than 2 times Joe's age. So Beth's age is 2. Okay, you get it. Let's go to the next sentence. Just for fun, we'll change the color for our ink. And the next sentence says the sum, that should call something to mind, of their ages is, again that word is, less than 33. Now this time the is and the less than are next to each other, so that's going to be a different symbol than before where we had the is was equal to. Is less than is an inequality. That's this less than symbol. So we have less than 33. Their ages are x and y, and the sum means addition. So what are we summing? What are we adding? Their ages, x and y. So we'll write the sentence like this. X plus y, the sum of their ages, is less than 33. And wouldn't you know it, we have two equations. Oh, wait a second. One of them is not an equation. It's an inequality. That's okay. We're going to keep on going and see if we can get this one, even though it's not, strictly speaking, a system of equations. So we're trying to figure out what Joe is, x equals, and it just so happens that we have our first equation in terms of y equals 2x minus 6, which is the requirement, what we need in order to find out what x equals. We are going to use the substitution method, so we're going to take our second equation, x plus y is less than 33, and substitute in place where we said y, what y equals, and y equals 2x minus 6. So we'll write 2x minus 6 there. And now we'll just simplify. X plus 2x minus 6 is less than 33, so we'll write 3x minus 6 is less than 33. We're going to add 6 to both sides. 3x is less than 39. Divide by 3x is less than, nothing's happened to change that less than sign, less than 13. So x is less than 13. So what is the oldest age that Joe could be if Joe's age is x and x has to be less than 13? What's the oldest age Joe could be? Well, the next age below 13 is 12. So Joe is at most 12 years old. That's the oldest Joe can be. Now if we were asked what's Beth's age, we could go back and plug that in. 12 goes into the 2x minus 6. 2 times 12 is 24, minus 6 is 18. So Beth must be 18 if Joe is 12. But this is what the question asked us, so we'll stop there. Moving on. Now I'm cheating a little bit here. We've got two questions, but I wanted to show you both types of these, and I've actually got two answers I'm looking for. We have this idea of interval notation, which we never talked about in a live class, but it's pretty important, and then the graph. And when we have only one variable, which is the case here, all of our variables are just x, then we're talking about graphing on the number line. So let's do this. These aren't solving situations. We're not solving anything, and in fact it's two problems. So let's put a dividing line there. In the first problem we have a sentence. -3 is less than x, which is less than 5. Interval notation, in this situation x is a number between two numbers. So for interval notation we're going to put those two numbers, -3 and 5, and a comma in between, and that just means the smallest x could be is -3, the biggest is 5, and then we need to put a bracket, some sort of bracketing symbol around this. Here's the clue. We put a square bracket if x is equal to that number, and we put a round bracket if x is greater than or less than that number. So in this case, x is greater than but not equal to -3, so we're going to put a parenthesis around the -3, and x is less than but not equal to 5, so we'll put a parenthesis around the 5. So that interval notation is saying that x is some number between -3 and 5, but not including -3 and 5. So that's how that works. Just for fun, let's let's do the graph next. So we're going to draw a graph, and obviously on a test, multiple choice test, most likely you're not going to be drawing the graph, so we won't make a big deal about this. But we're going to draw a number line, and our number line needs to include -3 and 5. So I'll put my middle 0 a little bit shaded to the left. 1, 2, 3, 4, 5. So there's 5. 1, 2, 3, 4, 5, -5. And when we say x is less than or greater than but not equal to, that means an open circle on those numbers. So an open circle on the -3, an open circle on the 5. And this is saying that x is a number between those two numbers. So we're going to draw our line between, connecting the two circles. And the line is supposed to be, if we've done this properly, it's supposed to actually be on the line. So it ends up just looking like a little bit thicker line than the actual number line. So hopefully that's clear. That's how I would do it if I was doing this with pencil and paper on a test of that type. All right, let's do the next one. And here, when we talk about interval notation, we've got two sentences instead of one. We have x is less than or equal to 4, or, and that's going to be a key word, x is greater than 7. So in that situation, or, we're going to use this union symbol. And that just means that obviously it's not possible for a value for x to be both less than 4 and greater than 7. So we're saying that all the numbers that are in one group or the other group, the group that includes numbers less than 4 and the group that includes numbers greater than 7, is going to be, so both groups are going to contain the possible answers for x. Okay, then that means we're going to have two intervals. The interval that goes all the way up to and includes 4, so x is less than or equal to 4, so all the way up to 4. We put a square bracket with the 4, comma. But what's the lowest number that x can be? When I say x is less than or equal to 4, I didn't specify how small x could be. So if it's not specified, it could be any number that's less than 4, all the way down to negative, as low as you want to go. We're going to say negative infinity. That's just a symbol that means keep going down and down and down as far as you want, or as far as you can. There's no limit to how small x can be. Because negative infinity is not an actual number, but it's more like a concept or an idea, we'll put our parenthesis on that side, because of course there is no such thing as negative infinity. It's just more like an indicating a direction that all the numbers that x could be are in that direction. Okay, then we also are saying, having the second statement that says x is greater than or equal to 7, which means that x could be equal to 7. So we put a square bracket. That's the smallest number in this interval that x could be, 7. The biggest number, what is that? Well, we didn't really specify a maximum number that x could be, so we put, you guessed it, positive infinity. And again, that is not a real number, so that's just more like indicating that we keep on going up forever. So we'll put a parenthesis on that end. All right, that is interval notation in the situation where you have the word or, meaning that there's two ranges combined together, and the U symbol says it's the answer for x is within both groups. How do we graph this? This time we need a graph that includes the number 4 and the number 7. So I'm going to put my 0 way down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I'm going to put a closed circle because x equals 4 and equals 7. Closed circle on 4, closed circle on 7. Notice I didn't have to write the number 7 in there. Everybody can see where the 4 is, where the 8 is, and count the rest of the little marks to where the other numbers are. And then x is less than or equal to 4. That means we're going to draw an arrow in the less than direction from that 4. And x is greater than or equal to 8. So we're going to draw an arrow in the greater than direction. And again, this is a way of indicating that x could be any number from either interval in this situation. Okay, that's all we have to say about that one. And then we're going to do it again. Now, here is a problem that's like that first one we did, where it's going to be that we're going to have the two ends of what x could be. X could be anything between two numbers. So we're not going to graph or do the interval notation here necessarily, but we're just going to solve. So we want to get x by itself. There's the x right there. But we have a problem. We've got two inequality symbols. So it's kind of like we have two inequalities going on here at the same time. The first inequality would be the middle section and the left-hand side. And the second inequality would be the middle section and the right-hand side. And you could get a problem that gives you two inequalities and end up with an answer much like the second example we saw on the last page. But in this case, we're going to do this combination of two inequalities with the x right there in the middle. So we're going to solve this as if we were solving two equations at once, and we're going to have three sides. So whatever we do to one side, we do to all three sides. So first of all, we're going to get rid of that minus 5 from the x. We've got 3x minus 5. Let's get rid of that by adding 5 to both sides of each equation. So plus 5 in the middle, plus 5 on the left, and plus 5 on the right. And we're left with 12 is less than or equal to 3x, which is less than 36. Then we'll divide by the number that's being multiplied by x. So x times 3, so we divide by 3. And whatever we divide the middle by, we have to divide the ends by. 12 divided by 3 is 4. Less than or equal to 3x divided by 3 is x. Less than, just the less than, 36 divided by 3 is 12. So 4 is less than or equal to x, which is less than 12. I lied, I'll do this in interval notation. 4 is less than or equal to, so we put a square bracket for the 4, and x goes from 4 all the way up to 12, but 12 is not included, it's not equal to, so we'll put a parenthesis there. So either way is a fine way of writing this answer. And let's move on to the next one. Alright, so now we're going to do inequalities, kind of like what we just did, but this time we're graphing them. And instead of giving you an inequality and asking you to graph it, which we'll do in a few minutes, I've asked you to examine a graph and figure out what the inequality it is that's being represented here. So the first thing we're going to look for is the line that is the border line for this inequality. That line is this dashed line here. And so we're going to find where that line hits the y-axis. That's called the y-intercept, and that is 1, 2, 3. So the y-intercept is 3, so y equals mx plus b. B equals 5. I don't know why I just said that. B equals 3. Let me fix that. Okay, b equals 3. The second part of y equals mx plus b that we're trying to find is the slope. And to find the slope, I'm going to just pick another point, and it just so happens that the x-intercept is a pretty nifty, nice number there. It's -2. So we can count the slope from there. And to do that, I'm just going to go from one point to the next. So from this point, I'm going to count how many spaces up and how many spaces over do I need to go to get to the next point. So from here to here, I go up 1, 2, 3, and over 1, 2. And I can try it again just to make sure that I'm right. 1, 2, 3, over 1, 2, back on the line again. Or I could go down 1, 2, 3, and over -2. 1, 2, 3, 1, 2. So from any point to any other point, I just need to go up 3 and over 2, or the exact opposite, which would be down 3 and over negative 2. So my slope then is rise over run. Remember, m stands for slope. Up 3 over 2. And again, if you said down 3 over negative 2, that would be the same number. Just the two negative signs would cancel each other out. So we won't say that. Okay, so let's then put those numbers into our formula for the equation of a line in slope-intercept form. Y equals 3/2, that's the slope, x plus, I was going to say b, but plus 3. Okay, now, there we have it. There's the equation of our line. Unfortunately, that's not what this graph is representing. It's not representing that line. That's just the boundary. What it's actually representing is this region, the shaded region, this lightly shaded region in orange down here. So how do I represent that? Well, you probably remember that when we had a y is less than something with the x, that was the region below. We shaded the region below the line. And if we said y is greater than, we shade the region above. So y is less than is the symbol we're going to use. And remember that if it was equal to, we would have a solid boundary line. But because this boundary line is a dashed line, we're going to say y is less than, but not equal to, 3/2 x plus 3. Now, that is a fine answer right there. That could very well be the answer. However, I want to take this one step further because it's possible that if this is a multiple choice question, they're going to give you answers that look different than that. So we might put this into what we call standard form, where there's no fractions and x and y are on the same side. And if we did that, I would first multiply everything by 2. So I'm just going to come in and multiply everything by 2, and I get 2y is less than 3x plus 6. So that is another fine representation of this line. Okay, you're going to see there's lots of fine representations. I could subtract 3x from both sides, so I get 2y minus 3x, or negative 3x plus 2y is less than 6. But if I like to have my x be positive and my y, if something has to be negative, I want it to be the y, I could subtract the 2y from both sides. So I have 3x minus 2y plus 6, and then subtract the 6 from both sides. And so I'd have 3x minus 2y and negative 6. And if I did that, then I would have had the x and y on the greater than side. Or it's possible that what I did is I took this sentence here and I just multiplied it by negative 1. And when you multiply an inequality by a negative number or divide by a negative, you flip the inequality sign and change all the signs. So it becomes positive 3x, negative 2y, negative 6, and greater than rather than less than. Okay, so just so you can see, there's lots of different ways to write the equation once we've figured out what it is, or the inequality. This is a fine answer. And if you see any of these other answers, you can turn them into this answer as you normally would when you wanted to find out what y equals in y equals mx plus b. Okay. Now we're going to do an inequality. And we're almost to the end, so hang on, we're getting there, although this is the second most involved question we're going to do today. Write the inequality that represents the graph. You're actually going to see several of these on the test, so we want to take our time and do a careful job here. I'm going to do the first one in red. And so I'm going to graph that first one here on the coordinate plane. Y is greater than or equal to negative 1/2 x. The y-intercept plus what? Plus 0. There's no y-intercept, no number given, so it's 0. And the slope is negative 1/2, so we go down 1 over 2. And we can just keep doing that if we want to, down 1 over 2 till we get confident in the direction our line is taking. And then we can draw a line, and I just realized I don't have a line drawing tool here, so I'm going to have to freehand this. Now, ask yourself, is this line going to be a dashed line or a solid line? Answer, y is greater than or equal to, so it's going to be a solid line. So there we go, we're drawing a solid line. This is not as easy as it looks, but you get the idea. Now, of course, on your test, you're not going to have to do this, at least not on part 1. You're just going to identify what that graph looks like, and so that, I think, might be the harder job, just taking a look at the equation and trying to decipher which of the lines on here are that line. Now, technically, when we're graphing an inequality, we're shading one side, and this says y is greater than, so we're going to shade the upper side, the top of this line. Instead of going ahead and just doing that, I'm going to just put a little arrow here to tell myself, shade the top of that line. That red line, we're going to shade the top. And then on my next line, I'll use different colors so that I don't get confused, or so that you don't get confused. I don't know, so one of us doesn't get confused. All right, in blue, we're going to graph x plus y is less than 2. Now notice this is not y equals mx plus b form. In order to get that form, I need to subtract the x from both sides. So I get y is less than, I could say 2 minus x, but I'm going to write it as negative x plus 2, because 2 minus x and x, negative x plus 2 are the same thing. That way I have my y-intercept right there, the plus 2. And my slope is negative. The negative, there's no number there, so I say it's negative 1, which is a fancy way of saying go down 1 over 1, negative 1 slope, down 1 over 1. If you write negative 1 as a fraction, you would write negative 1 over 1. And down 1 over 1, down 1 over 1 a bunch of times, or up 1 over negative 1, the exact opposite. And there we go. Now, am I going to do a solid line or a dashed line this time? Dashed line is right because it is not equal to, it's just less than. So I'm doing a dashed line and trying to do a good job of getting it fairly straight, but you don't have to worry about that. Now, in this case, y was less than, so we're going to shade the underneath side of this line. So I'll put a little arrow there again just to kind of remind me that eventually we're going to shade the underneath region of that blue line, the upper region, above region of the red line. Let's get one more line in here before we do that. We'll pick a green. I think I can distinguish green from blue. This one is in slope-intercept form. It's y is greater than or equal to 3x minus 5. So we'll start out at negative 5. The y-intercept is negative 5. Slope is 3x, 3 as a fraction is 3 over 1. So we go up 3 and over 1 to get to our next point, up 3 over 1. And that's going to be a bear to freehand in my straight line here, but we'll do the best we can. This is also an equal to situation, so we're going to do a solid line here. Not too terribly bad. Okay. And y is greater than, so we're graphing the top side of that line. Now it's a little bit harder to see the top of this line because it's so close to being straight up and down, but I think you can see that the above side of that line is the predominantly left side of the line. Okay. So now we're looking at this and we're going to shade in a region here. But before we do, I wanted to just point out that actually the big thing that you're going to be asked to do on this test, and it's actually several times, is to identify not the graphs where the lines fall. You're going to get all your graphs are basically going to look the same. They're all going to look like this one. But then the question is, which region do we shade? Are we shading this region in here, this region here, this one? There's lots of different region choices. So which of these regions are we shading? And that's what's going to be tricky. So it's the region that's to the left of or above this green line, below the blue line, above the red line. So it's this region right there. I'll just see if I can get that shaded in here with my highlighter tool so you can see it. Okay, not a very neat job, but you get the idea. That region is the region that is the solution to this system of inequalities. Last one. Now, this question, crazy question, is so difficult. I wanted to make it more interesting to you, something that you could relate to. So this is about using your allowance to buy new records and 8-track cassettes, because I know that's probably what you guys spend all your money on. And this question has 3 parts, and I'm going to let you in on a secret. You're only doing the first part on your test, so I'll probably go really fast over the last 2 parts. You're going to use your allowance to buy some new records and 8-track cassettes. You want a number of records to be more. You want the number of records to be more than. Right, there's your inequality, greater than twice the number of cassettes, and there's some math words, right? Twice, we've seen that before, 2 times the number of cassettes. So let's say cassettes are C and 8 tracks. Records are R. So R is greater than 2C. We can write that down. R is greater than 2C. Records cost $3 and 8 tracks cost $5. And you only have $18 to spend. So now that's going to be a tough equation to write, but let's think about this carefully. If records cost $3, then the amount of money you spend on records is 3 times R, because $3 per record. So if you buy 1 record, it's $3. 2 records is 2 times 3 is $6, and so on. Okay, and how much money do 8 tracks cassettes cost? $5. So the money you spend on the cassettes is 5 times C, and then we're going to say the total amount of money you spend is 3R plus 5C, and you only have $18, so you can only spend less than or equal to $18. You can't spend more than $18, you don't have it. Alright, so there's a second equation. Now, this is what's tricky about this one. There's actually 2 other equations that are implicit here but are not written down, are not expressed anywhere in words. The 2 equations are this. You're going to buy some records. That means that you're going to have some number of records that you purchased that's bigger than no records. Right? You're going to buy some records, so you're going to buy a number of records, so R is greater than 0. And you're going to buy some 8-track cassettes, so C is also going to be greater than 0. So you can't say, I'm not buying any records, because then you wouldn't be meeting the constraints of this question. Okay, now, before we move on to the next part, let me just spend a few minutes here. This is the hardest kind of question you're going to see, because this is that crazy kind of question that we never like, that has those little boxes and you have to check all of the correct boxes. So that if you did the hardest one on here and said 3R plus 5C is less than or equal to 18, that was really hard. It took me like 30 minutes to puzzle that one out. You'd get it wrong, because you also have to check the easy one, R is greater than 2C, and the implicit ones, R is greater than 0 and C is greater than 0. So unless you get all of those equations, you haven't finished this part of the question. Okay, now let's graph this, and instead of using X and Y, I used R and C. By the convention, we'll usually have the alphabetical order. C will go there and R will go here. It doesn't have to be that way. So if R is greater than 0, that's going to be this line. right here, and we're going to shade above it. And if C is greater than 0, that's going to be this line. Basically, those are fancy ways of saying that R and C are going to be positive numbers, so we're in the first quadrant of our coordinate plane. The first equation, R is greater than 2C, so that's going to be y-intercept of 0, 0, and then 2C is the slope up 2 over 1, and greater than, not equal to, so we're going to do our line like this. I should warn you, I did not check this out before. Since R is standing in for a y-intercept, we want to solve this equation, this last equation, which is the second one on my list here, for R. So I'm going to subtract 5c. So I get 3R is less than or equal to negative 5c plus 18. And divide by 3, R is less than or equal to negative 5/3 c plus, I think that's 6. So y-intercept is 6, go up 6, 1, 2, 3, 4, 5, 6. And the slope is negative 5/3, so we go down 5 over 3. And less than or equal to. Now, here's the tricky part here. Our important points are going to be at the corners of these graphs. So let me get a different color and highlight those important points. The important points are right there, and right there. And I'm not going to spend a whole lot of time here, but remember C is the number of cassettes. And if this were an accurate line, this point here, the value of C, would not be a whole number, 1, 2, 3 point something. Let's C is 3.8 or something like that. I'm not positive. But clearly, C is not equal to 4 at that point. So we're going to say we can't have a fraction of a cassette, and according to the graph, I'm sorry. Ooh, I just about did this wrong. Remember that dotted line that we drew here, R is greater than 2C. We need to shade above that line. And then this last one we did, R is less than, so we're going to shade below that line. So our region is right here. Wow, I almost messed that up. It's right in here. Okay, the shaded region is in there. You were probably yelling at your computer screen. Mr. Tucker, what are you doing? Okay, there's the shaded region, and that region tells us that we'll change colors again because I was about to mess up, so let's do this again. That region tells us that either this point, or this point is going to be the kind of the key points, the most important points. So obviously 0, 0 is not what we want. We don't want to buy 1, 2, 3, 4, 5, 6 records and 0 cassettes. We want to buy some 8-track cassettes. So I'm looking at this point here, and this is the tricky one. It's not on the line. It's something like 1.5, 1, 2, 3.5. Let's just say it's 1.5, 3.5. So obviously we can't round up and buy 2 8-track cassettes. So we'll say that the biggest amount is up to 1.5, so the biggest whole number would be 1. So the most we can buy under the conditions we've set for ourselves is 1 8-track cassette, and then however many records we can afford after that, maybe 3 or maybe 4. But the question said, what's the most 8 tracks we can buy under these constraints, and that's the answer. Okay, so don't worry about those last 2 parts. The big deal for you is just identifying what the equations are, or the inequalities in this case. And that's all I have. Thank you for watching. Enjoy the unit test. Do your best. Let me just say, if I could just put this plug in, if you have 100% on all your quizzes, I know you'll do great. If you have 80% on all your quizzes, you're going to do pretty good. If you haven't mastered all of the quizzes, don't take the test yet. Come in and see me in Math Help. I'll get you past those ones so you understand what you're having trouble with in those tricky quiz questions that you keep getting wrong. And then you're going to do much better on your unit test. So don't be in a hurry. Don't be in a rush. Get it done right. Thank you very much for watching.